Hi, this is Terry. Welcome to another podcast. Today it's about my struggles with GeneWeb, where I try to resurrect the family tree I made in 2018, which was a massive amount of work. It involved all kinds of research across various countries to track down my forebears, their military records, marriages, dates of birth, and death. I also had a lot of trouble with funding the most expensive AIs, which are also the best. I conclude with discovering a ghost in my browser and the fight to remove it.
Welcome to today's deep dive. So usually when you save a file to a hard drive, you probably think of it like putting a physical photograph into a shoebox.
Right. Yeah, like it's just safe in there.
Exactly. You just slide it in, put the lid on, tuck it into the closet. And I mean, the implicit expectation is that 10 or maybe 20 years from now, you could lift that lid and the picture's exactly the way you left it.
Yeah, the colors might be a bit faded in your memory, but the artifact itself is frozen in time.
Right.
And, that illusion of local storage is incredibly powerful. People treat their digital archives as inert physical objects. You just assume that holding the raw data files guarantees your ability to experience that data whenever you want.
But if you step into the actual reality of software architecture, you quickly realize that Shoebox isn't just locked. The lock itself is mutated.
Oh, totally.
The key you use to open it doesn't even exist in the physical universe anymore.
Yeah.
And the atmosphere inside the box has become fundamentally toxic to the contents.
Which is pretty much the definition of digital decay. I mean, software doesn't exist in a vacuum. It requires this highly specific, constantly shifting environment to survive.
Which brings us to Terry, the subject of today's deep dive. He's a 72-year-old retiree living in Australia. And back in 2018, he did something really incredible.
Yeah, he built this massive family tree.
Meticulously built it. We are talking about 80 individual people, 32 distinct families, and 48 historical family photos. And he constructed this entire archive inside an open-source genealogy server called GeneWeb.
Which, to be fair, was a very solid choice for 2018. GeneWeb was robust. Terry had it running on a FreeBSD machine, which is a famously stable Unix-like operating system.
Right.
But I mean, hardware has a finite lifespan. Eventually, that FreeBSD box suffered a hardware failure and just went dark.
Now, Terry isn't a novice, He actually followed best practices to the letter. He didn't just have a loose folder of files. He maintained a fossil version control repository.
Yeah, that's a big deal.
It is. For those dealing with large projects, Fossil is fantastic because it's a distributed system. It backs up the entire history of the project, all the commits, the configuration files, the database, the JPEGs, and even a plain text export of the data.
So he had the ultimate, theoretically bulletproof digital shoebox.
Exactly. So he buys a new modern Linux machine, downloads his Fossil repository, and it hits a massive brick wall.
Right, because having the data is meaningless if you don't have the exact precarious Jenga tower of dependencies required to interpret it.
Oh, I love that analogy, the Jenga tower.
Yeah, I mean, Terry couldn't just double-click an installation file on his new Linux machine. The pre-packaged version of GenWeb available on Linux immediately threw a compilation error. It basically demanded manual intervention.
Right.
He had to build the software from absolute scratch using the original source code.
Okay, let's unpack this. For beginners, compiling from source is kind of like trying to bake a cake using a recipe that's written in a language where the vocabulary keeps changing every few years.
That is a perfect way to put it.
So he's sitting there with all his database files, the JPEGs, the config files, and my initial thought is, well, just point the freshly compiled GeneWeb to the old directory and you're done. It's just a file path, right?
You think so, yeah.
But the compilation itself is where that Jenga tower starts wobbling. GeneWeb was written in a programming language called OCaml. And Terry, amazingly, successfully navigates building it from source.
Which is no small feat.
Totally.
Okay.
He gets the web server running on his local machine, opens his browser, navigates to the port, and the welcome page of his family tree loads flawlessly.
He was probably feeling a massive sense of relief right there, like problem solved.
Oh, 100%. The text is there, the logo is there, but then he clicks on an actual family member's name to view their lineage, and boom.
It drops.
The entire server crashes instantly. It returns a completely empty response. So the front door opens, but the moment you step into the hallway, the entire house just collapses.
Yeah, and to understand why that happens, you really have to look at how the web server communicates with its underlying data.
Right.
That welcome page Terry saw was largely static. It's surface-level HTML that doesn't require the server to do any deep thinking. But clicking on a specific person, That triggers a complex query.
Gotcha.
The software suddenly has to dive deep into the database, calculate relationships, retrieve birth dates, fetch specific photos from various directories, and dynamically assemble a new page on the fly.
That's a lot of heavy lifting.
Exactly. That requires the core database engine to physically parse the stored data. And Terry's newly compiled Jenga tower just couldn't handle the weight of that request.
It's sort of like a restaurant. The welcome page is just the menu taped to the front window. Anyone can read it without bothering the staff.
Yeah, perfect analogy.
But clicking a person's name means sending a complex custom order into the kitchen. And in this case, the kitchen staff, the database engine, just drops dead upon reading the ticket.
Yep, they just walk out.
So Terry is totally stuck. He has the data, he has the tower built, but it keeps collapsing. So he decides to call in an artificial assistant to figure out why the kitchen is failing.
Right. He opens up an interface called OpenCode and spins up DeepSeek Pro.
And DeepSeek is fascinating in this context, right?
Hmm.
Because it's known for being highly methodical and incredibly cheap.
Very cheap. We are talking about like $1.50 an hour in compute tokens.
Wow. And DeepSeek immediately starts doing what AI does best, which is reading the microscopic fine print. It digs into the hidden server log files and uncovers the fatal error that caused the crash.
Yeah, the log read #TBL unsupported hash table format.
Okay, an unsupported hash table format error. And that is basically the absolute nightmare scenario. A hash table is essentially the internal filing system, right? The index a database uses to instantly locate data without scanning every single file.
Exactly. If the database can't read the hash table, it's totally blind. It doesn't know where anything is.
So the Jenga piece
Yeah.
at the very bottom of the tower had fundamentally changed its shape.
Right. So Terry's 2018 database was written using version 4 of the OCaml programming language, but his new modern Linux system compiled everything using OCaml version 5.
And that's the disconnect.
Yeah. Between version 4 and version 5, the developers of OCaml didn't just update some syntax. They completely redesigned how the language allocates memory for hash tables.
Oh man, it's like trying to play a vintage vinyl record on a brand new high-end turntable, but discovering the new needle is physically 3 times too wide for the old grooves.
That's exactly it. The music is still locked inside the vinyl, but the hardware designed to read it is now actively destroying the output.
So OCaml 5 looked at the old hash table structure, which GeneWeb apparently stored in a file called patches, and basically declared it radioactive.
Fundamentally incompatible. So DeepSeek, costing Terry $1.50 an hour, puts in this massive methodical effort to bridge the gap.
What did it actually try to do?
Well, over the next 2 hours, it tries to downgrade the environment. It attempts to build GeneWeb using older versions of OCaml, specifically aiming for 4.14 instead of the modern 5.5.
Oh, trying to roll back time.
Yeah, and it traces the software crash through 11 different layers of function calls.
Okay, tracing 11 layers deep is intense. That means the AI is reading a function, seeing where that function calls another piece of code in a different file, following that thread, and doing that 11 consecutive times, trying to find a place to safely inject a fix.
It's a ton of work. DeepSeek even finds that plain text export Terry saved, re-imports all 80 people from scratch, and attempts to compile a completely fresh setup. It made 16 different code commits to the fossil repository during this process.
Yeah, there's a catch, right?
Yeah, here is the tragic part of relying on methodical, cheaper AI models for deep architectural issues. The server would start, the search function would work, but the moment you queried an individual person page, the tower elapsed again.
Oh no.
DeepSeek got trapped in a death loop.
Because it's trying the same architectural fixes in a sandbox that fundamentally rejects the premise. It identifies the failure, proposes a patch to ignore the error, but the compiler refuses because the binary structure of the patches file is already baked in the old format. It fails, and DeepSeek tries again from a slightly different angle that hits the exact same wall.
Over and over.
2 hours of grinding, $3 in API tokens burned, and Terry is no closer to actually seeing his family tree.
Right, so he realizes a commuter car isn't going to win this race. He needs brute intellectual force, and he needs it immediately. So he hits the escape hatch and pivots to Claude. Specifically, Claude Sonnet v4.6.
And this is where the token economy of modern AI becomes a very real factor, especially for a retiree. DeepSeek was $1.50 an hour. Claude runs roughly $15 an hour.
Yeah, it is 10 times the price for that brute force.
10 times. The source material actually details Carey's reaction when he fed the repository into Claude, and it highlights a stark difference in how these models operate.
Right, Terry was watching his token counter the meter tracking his spending. With DeepSeek, it ticked along at a predictable, writable pace.
Like a taximeter.
Yeah. But when Claude engaged, Terry described it as an aircraft altimeter in a steep dive. The numbers were just a blur.
Which really begs the question, why is it burning through tokens at that terrifying velocity? Is Claude just inherently less efficient at reading the code?
No, it's the exact opposite, actually. A Claude burns tokens because of its massive parallel context window. It wasn't tracing one function at a time like DeepSeek.
Okay.
Claude was shoveling terabytes of context into its reasoning engine simultaneously. It was reading dozens of files in parallel, instantly cross-referencing the entire codebase of GeneWeb to build a three-dimensional map of the architectural flow in its working memory.
So instead of one investigator slowly following a string through a maze, Claude basically dropped 1,000 speed readers into the maze at once, mapping every dead end instantly.
Exactly. And the intellectual fix it came up with is genuinely brilliant. Claude didn't try to downgrade the tower back to OCaml 4 like DeepSeek did.
What did it do instead?
It leaned entirely into the new architecture. Claude wrote a custom wrapper function directly into GeneWeb's source code.
Okay, explain how that wrapper actually functions in practice, for the beginners out there.
Sure. It essentially acts as a real-time translator sitting between the radioactive data and the new system. When the database tried to retrieve a family member, Claude's wrapper intercepted the memory request meant for the OCaml 4 hash table.
Oh, I see.
Yeah, it caught the old primers, mathematically translated them into the new structure OCaml 5 expected, and then fed them to the new memory allocator.
It built a microscopic real-time adapter for that oversized vinyl needle we talked about earlier.
Precisely. Claude also identified and purged stale cache files that were confusing the routing, and it ran a legacy utility called a notes linker to reconnect the text data. And suddenly GeneWeb ran.
Wow.
The person pages loaded dynamically without crashing the system.
That's incredible. But because legacy software is never entirely fixed, there was one final trap, wasn't there? The system was stable, the text loaded, but all 48 family photos were completely gone.
Yep, just broken image links across the entire tree.
GeneWeb has an infamously bizarre quirk regarding how it handles media directories. The file path it uses to look for your photos is entirely based on where the primary configuration file is physically located.
It makes absolutely no logical sense.
None. It's like a car where the steering wheel controls the radio if you happen to park facing north.
Yeah. But Claude figures out this directory path quirk, updates Terry's internal wiki documentation so he doesn't forget it, and then Terry makes a highly strategic choice.
Which is?
Well, he realizes that keeping this legacy system alive requires a $15 an hour AI translator. So he asks Claude to export the entire database out of the fragile OCaml environment completely.
Right. He wants the holy grail of data preservation, a GEDCOM file.
Exactly. GEDCOM is the universal standard format that virtually every modern genealogy program on Earth can parse natively.
The export wasn't perfectly clean, though. Only 35 out of the 48 photos successfully linked in the new format.
True. But Claude threw together a quick Python script to parse the text file, locate the broken image paths, rewrite them, and sew the final 35 photos into place.
That is wild. 30 minutes. That is all it took Claude to shatter an architectural deadlock from 2018 that the cheaper AI couldn't even dent.
But 30 minutes of a spinning token altimeter forces a serious budget pivot for someone on a fixed income.
Yeah, here's where it gets really interesting. We have to talk about Terry's reality here. He's 72. He is watching his wallet carefully.
Right.
18 US dollars might be, a few lattes in San Francisco. But for Terry, adjusting for the exchange rate, it's $25.50 in Australian money. And this rescue happened halfway through the month. His allocated AI budget is bleeding dry.
So having secured his family history in that universal GDCOM format, Terry decides to abandon GeneWeb entirely for his daily use.
Probably a smart move.
Definitely. He wants to install a modern genealogy software called WebTrees, which is built on PHP.
And PHP is vastly easier to maintain and host than compiling obscure OCaml repositories.
Absolutely. But because Claude burned through his budget rescuing the data, he has to downput his AI to actually build his new system. He puts DeepSeek back to work on the WebTrees installation.
And immediately, they hit a bizarre new hurdle that has nothing to do with OCaml or PHP. Terry tries to run the WebTrees installer, And the browser throws a completely nonsensical error.
Yeah.
The connection is refused not by the server, but by a ghost living in the machine.
Literally. Terry was using the Brave web browser, and DeepSeek uncovered that Brave's cache was actively holding on to an old service worker.
And for those listening, a service worker is essentially a background script that browsers use to enable offline functionality or push notifications.
Right. Terry previously had an old neural network interface running on port 8888.
And even though that neural network program was long dead and uninstalled, its service worker was still haunting port 8888 inside the browser's memory.
Yes. So when WebTrees tried to load on that same port, the browser intercepted the network request and routed it to the dead neural net script instead of the live PHP server.
It was a literal ghost hijacking the signal.
It was, and this is where DeepSeek actually proves its distinct value. It couldn't write a real-time memory allocator for OCaml, but it was incredibly patient.
Right, it didn't rush him.
No, it guided Terry step by step through Chrome developer tools, showing him exactly which menus to open, which checkboxes to clear, and how to manually unregister that specific service worker to exorcise the ghosts from the cache.
Then DeepSeek solved one final database mismatch. WebTrees kept crashing because its default configuration file expected a heavy-duty MySQL server, but Terry opted for a lighter SQLite database.
A very common issue.
Yeah. But DeepSeek spotted the mismatched variable, provided a simple one-line fix in the PHP config file, and WebTrees finally launched.
The irony is just fantastic. The cheap AI was completely out of its depth with the deep architectural coding, but it was the absolute perfect cost-effective tool for holding a user's hand through modern browser quirks and one-line setup fixes over a long, slow period.
It's a perfect demonstration of how you have to actively manage these tools based on their specific strengths and, frankly, your available budget.
For sure.
So let's zoom out and analyze the final tally of this tech rescue.
Okay, so Terry spent 2.5 hours grinding with AI. He generated 8 separate wiki pages of system documentation for himself. And the total cost across both platforms was roughly $18 in API tokens.
Which, again, is over $25 for him. But looking at Terry's experience with that $18 bill, a very clear picture of the broader AI landscape emerges.
Yeah, you really see the tiers of capability.
Right. You have tools like DeepSeek representing the current tier of Chinese AI tech. It's generally estimated to be about 30% less capable at highly complex frontier coding tasks compared to American models.
It's the commuter car.
Exactly. It thinks in loops, it traces slowly, and it gets stuck in death loops when the architecture fundamentally shifts. But it is cheaper. It is your daily driver for routine debugging, checking logs, and guiding you through menus.
Then you have Claude. Claude is the Formula One race car. It is breathtakingly fast, it reads the entire codebase in parallel, and it will throw massive compute power at utterly impossible legacy bugs to shatter them.
But it burns high octane, incredibly expensive fuel.
Right. You do not use Claude to check your PHP settings. You keep it in the garage strictly for emergencies when the house is collapsing.
So what does this all mean for us? Looking at Terry's migration, it really hits me that backing up the data in that fossil repository was only half the battle.
Oh, absolutely.
The real threat was the environment decaying around it. So can you give us the 3 key takeaways regarding software maintenance cycles based on this story?
Yeah, definitely. Takeaway number 1, underlying foundations decay. Having a backup of your files is not enough if the programming language those files rely on changes its internal structures. Data without its specific execution environment is basically just radioactive noise.
Wow, yeah, that makes total sense. What's number 2?
Number 2, ghosts in the machine linger. Even when you escape that decaying environment, you aren't starting with a clean slate. When Terry moved to WebTrees, that ghost service worker hijacked the port.
Right, the browser cache.
Yeah, when you are modernizing a system, old configurations, abandoned network ports, and cached browser files will actively sabotage your new software. You are constantly fighting the residue of the past.
And the 3rd takeaway?
Number 3, escape to universal formats. The ultimate goal of legacy maintenance isn't just to keep a fragile legacy system limping along on a modern machine. The goal is to pry the data out and extract it into universally accepted plain text standards like the GED-COM file.
Because that ensures your information survives the next decade without needing a Formula One AI to open it.
Exactly. And ultimately, Terry won the war. His family tree is now safely running on 3 completely different systems.
Yeah, he has the original AI-patched GeneWeb running on port 2318. He has the modern PHP-based WebTrees software running cleanly on port 8888, and he has that golden GED-COM file safely backed up ready to be read by any future application.
A total victory engineered out of a digital dumpster fire.
Truly. And to you listening, you don't need to be compiling obscure code on a Linux box to face this exact decay. This is about those digital photos sitting on a hard drive you haven't plugged in since 2014.
Or that novel you started writing in a proprietary word processor that went out of business 5 years ago.
Exactly. Digital decay is coming for all of it.
It is a relentless, ongoing battle against entropy.
Which leaves me with a final, slightly haunting thought for you to mull over. We just watched Terry spend $18 using an unimaginably advanced, token-guzzling AI just to pry open a simple family tree that was less than 10 years old.
Yeah.
But what happens in 50 years when the AIs themselves become legacy software? When the architecture behind Claude and DeepSeek is viewed as an ancient, incompatible relic of the 2020s?
That's a terrifying thought.
Right. Will we eventually need an entirely new, even more resource-intensive intelligence just to decipher and translate the obsolete code written by today's AI? When the key that opens the shoebox is itself locked inside another decaying shoebox, who do we call that?
Guess we'll find out.
Thanks for joining us on this deep dive. Export your files to universal formats, clear your browser cache, and we'll see you next time.
This concludes the podcast. Thank you for watching. I hope you have found this podcast useful, and as always, if you have any constructive comments, I would like to read them, so drop them in the comments section below.